Welcome to a new video. In this video, we shall discuss the discovery of neutron, and we shall discuss Bohr atomic model. Let us quickly talk about discovery. Let us quickly discuss discovery of neutron. Discovery of neutron. Discovery of neutron. Neutron was discovered by a man called James Chadwick. This man worked together with what? Ernest Rutherford. He worked together with Ernest Rutherford. The man discovered what? Neutron. James Chadwick discovered neutron using beryllium foil experiment. He used beryllium foil experiment. How did he use this experiment? How did he perform this experiment? How did he perform this experiment? He bombarded, James Chadwick he bombarded beryllium. He bombarded beryllium foil with alpha particles. He bombarded beryllium foil with alpha particles. And he discovered a neutral radiation, which he called the neutron. He discovered a neutral radiation that passes through the world, the beryllium foil, and which he later called what? A neutron. He discovered a neutral radiation, which he called the neutron. That means the man that discovered neutron is known as what? James Chadwick. He used beryllium foil experiment. He bombarded the beryllium foil with what? Alpha particle, and he discovered a neutral radiation. Let's move on. Then let us go to what? Atomic model of Bohr. Bohr atomic model. The man that proposed the idea that proposed what? Planetary of what? Atom. He proposed the planetary of atom. But the idea, whose idea was planetary of atom? The idea of planetary of atom belongs to what? Ernest Rutherford. But the man that proposed that idea is known as what? Bohr. The idea of planetary of atom is what? Ernest Rutherford. Then the man that proposed the planetary of what? Atom is what? Bohr. Bohr proposed the planetary of atom. That means he said that what? An electron revolves around the nucleus like what? The earth revolves around the what? Sun. Is the one that proposed that planetary of atom. But the idea, whose idea? What? Planetary of what? Atom. Whose idea was that? Ernest Rutherford idea. But the man that proposed it, and Bohr proposed that planetary of atom. Then let us look at Bohr atomic model. Bohr atomic model. We are going to be fast, and we look at some formulas under this. Very unique formula. The first one, it says atom has a central particle called nucleus. Take note of that. That was the first thing. He said atoms has a central particle called what? Nucleus. That was the first thing he said. That atom has a central particle. That inside an atom there is a central particle that is called what? Nucleus. Let's move. The second one. He said electron revolves around nucleus in a fixed circular path called what? Orbit. Electron revolves round the nucleus in a fixed circular path, path called orbit or shell, with fixed energy and fixed velocity. Take note of that. He said, electron revolves round the nucleus in a fixed circular path called what? Orbit or shell. Now, electron revolves round what? The nucleus in a what? Fixed circular path called orbit or what? Shell, with what? Fixed energy and what? Fixed what? Velocity. Number three. He said, electron does not lose or gain energy. Electron does not lose or gain energy in its shell or orbit. Take note of that. That means when electron is in its orbit, it does not lose or gain electron. That when electron is what? Is revolving around its own orbit. That when you have electron in its shell, it does not lose or gain what? Energy. When you have electron in its shell, it does not lose or gain energy. Number four. He said, electron gains energy. That means absorb. That means absorb. Gains energy or absorb energy when it moves from lower energy level. Energy level is known as shell. Lower energy level, that is shell or orbit. Lower energy level to higher energy level. Electron gains energy when it moves from lower energy level, which is shell, to higher energy level. It loses energy when it moves from higher energy level, that means higher shell, to lower energy level. That means lower shell. Let me explain this. Please, let me explain this. Now, electron, when you have electron moving from lower energy level to higher energy level, when you have, this is lower energy level, K shell, higher energy level, L shell. When you have electron moving from this lower energy level to this higher energy level, that is called excitation. Excitation is called excitation. When there is excitation, when electron move from lower energy level to higher energy level, that's what electron absorb energy, that it gains what? Energy. But when it's now moving from higher energy level to lower energy level, when electron is moving from higher energy level to lower energy level, from higher shell to lower what? Shell, in that case it loses what? Electron. That process is what? The excitation. that when there's excitation of electron moving from lower shell to higher shell, electron gains what? Energy. But when what? There's the excitation that electron is moving from what? Higher energy level to lower energy level. That means the electron loses what? Energy. Take note of that. Then let's move. The next one, number 5. You can pause the video and write it. Number 5. Number 5. You can pause the video. Number 5. Number 5. That it says the angular momentum of electron is quantized. Number 5. It said the angular momentum of electron is what? Quantized in the shell. Number 5. Angular momentum of electron is quantized in a shell. The angular momentum of electron is quantized in a shell. That means we have angular momentum equal to what? NH over 2 pi, where n is what? Positive integer. Where n is what? Positive integer. Which could be what? 1, 2, 3, 4, and also on. Take note of that. It says angular momentum of electron is what? Quantized in a shell. Angular momentum of electron is quantized in a shell. And angular momentum is what? Integral of multiple natural number. Integral of multiple natural number. Take note of that. Then we also have angular momentum F equal to what? The radius of what? Of shell or energy level. The radius of shell times what? Linear momentum. Take note of this. Angular momentum equal to what? The radius of shell multiplied by what? Linear momentum. And what is linear momentum? Linear momentum is what? Mass times velocity. A product of mass and velocity. And this is mass of what? Electron. M is what? Mass of electron. V is what? Velocity of what? Electron. Velocity of electron. Then substitute your P with this formula because you have linear momentum, which is P, equal to what? Mass of electron multiplied by the what? The velocity of electron. Then change this linear momentum. We have angular momentum equal to what? RmV. That means I can simply write angular momentum equal to what? MVR. Take note of this formula. Take note of this formula. Take note because I will still play with those two formula. And I can equate the two. Angular momentum equal to NH, where H, what is H? H is what? Planck constant. Take note. H is what? Planck constant. And L equal to this, the same angular momentum equal to this. That means I can have MVR equal to NH over 2 pi. Take note of this formula. Please, because I will play with the formula. I will play with that formula. I will play with that formula. Take note. It says angular momentum of electron is quantized. That means they are in what? In a fixed what? In a fixed quantity. They are in a fixed quantity. In a discrete packet is quantized. And we have angular momentum equal to NH over 2 pi. What is N? N is what? Number of shell. It could be 1, 2, 3, 4, and what? So on. K shell, don't forget, K shell is when N equal to 1, that is what? K shell. When N equal to 2, that is what? L shell. When N equal to 3, M shell. When N equal to 4, N shell. Take note of that. Let's move. Take note of this formula. I need this formula. Let's move. Let's go to the next one. Let me rewrite the formula here because I will play with the formula. You can pause the video and write them out. I will play with the formula. I will play with the formula. I need to play with the formula. I have, let me write it here. MVR equal to NH over 2 pi. This I need this. I need this. I need this. Number 6. Number 6. Number 6. Number 6. It says the electrostatic force between electron on its shell and nucleus. The electrostatic force between electron and nucleus of an atom provides centripetal force. Take note of this. If they ask you, what kind of force occurs between a nucleus and electron on what that revolve around the what nucleus? Take note when you have this, when you have this. This is a nucleus according to Bohr, nucleus, and you have electron. The force, this is electron. The force of attraction between these two is known as what? Electrostatic force. Electrostatic force. And don't forget, let me give you this bonus. Inside the nucleus, I have proton and what? Neutron. Inside the nucleus, I have proton and neutron. It's a bonus. What force occurs inside the nucleus? The force that occurs inside the nucleus is known as nuclear force. Nuclear force. Take note. Inside the nucleus of an atom, the force that occurs inside the nucleus of an atom is known as a nuclear force. That means nuclear force occurs within the nucleon. Nucleons are the particle inside the nucleus. The nucleon inside, between the nucleon, the force that occurs is nuclear force. But I'm not talking about that today. Let's move. Then it says the force of attraction, which is electrostatic force between the electron and the nucleus, provides what? Centripetal force. It provides centripetal force. That means I have centripetal force is the same thing. Centripetal force is the same thing as what? Electrostatic force. Take note of that. Centripetal force is the same as electrostatic force, because the electrostatic force is providing what? Centripetal force. They are the same. Therefore, what is centripetal force? We have centripetal force. Let me use C. Centripetal force. Let me use C. Centripetal force equal to what? mv squared over r. And what is electrostatic force? According to Coulomb law, electrostatic force is 1 over 4 pi epsilon. Then quantity of what? Charge, the product between two charges over what? R squared. Take note of this. What will I do? Don't forget, I'm talking about what? Electron and what? Nucleus. And inside the nucleus, we have a particle called proton, which is positively charged. The charge of an electron is the same thing as the charge of the proton. According to Coulomb law, the charge of electron is the same thing as the charge of a proton, but opposite what? Charges. The value, the magnitude, they are the same, but opposite what? Charge. The value of the charge of what? Electron is the same thing as the value of the charge of what? Proton, according to Coulomb's law, but what? Opposite charges. Therefore, I can simply say, if we have, this is nucleus. Inside the nucleus, I have proton. Then, this is what? Electron. The force between them is known as what? Electrostatic force. Then this is radius. The square of radius. The charge of this, they are the same. Let me use E for the charge. But inside the proton, I have what? Number of what? Proton, a certain number. I use Z for that word, the number of proton. And don't forget, number of proton is the same thing as atomic number. I use Z for the what? For the number of proton, which could be 5, it could be 6. I use Z for that number. But they have the same charge. It's just that this one is negatively charged, this one is positive charge. But they have the same word charge. I'm using what? Z for the number of what? Of proton. Then substitute this to this. Q for proton is what? ZE. Q for electron is what? E. Substitute that into this. What will I have? I will have electrostatic force equal to 1/4 pi epsilon naught. Then this one will what? ZE times E/R square. What will I have? Electrostatic force equal to 1/4 pi epsilon naught. Z times E will give you E times E will give you E square. And we have ZE square over R square. Then let's come back to this. What is centripetal force? Change it. NV square over R equal to what is electrostatic force? 1/4 pi epsilon naught ZE square over R square. Then from here, let us do some mathematics. 1/2 from here, cancel this R. What will I have? I have NV square equal to what? 1/4 pi epsilon naught ZE square over R. Make V square the subject of formula. This one we call it. We have V square equal to 1/4 pi epsilon naught times what? Mass. Then times what? ZE square over R. Take note of this formula. You can pause the video and write it down because I will play with that formula also. I will play with that formula. You can pause the video, write it down. I will play with that formula. Pause the video and write it down. This Q is what? Number of proton multiplied by the charge of proton. This second Q, let me Q1, Q2. Let's say Q1, Q2. Q1, Q2. Q2 is what? The charge of electron. They are the same. It's just that they are opposite. They are the same. That's why I'm using the same EE. Then you have this. Substitute them, you have this. Then do S centripetal force, which is this. Change it. Equal to electrostatic force, which is this. Change it. Then do your mathematics. Make V square the subject of formula. Okay? Let me rub this one. Then from here, I have, let me write down formula here. V square equal to 1/4 pi epsilon naught mass ZE square over R. I have that. Take note of this formula. Let me put it here. Let's move. Then from here, I want to calculate the radius of an atom. The radius of what? Of shell of an atom. The radius of shell of an atom. Let me recall this formula because NVR equal to NH over 2 pi. Square both sides. Square both sides. If I square both sides, I will have N square, V square, R square equal to N square, H square over square, that is 2 square, will give you 4, then pi square. Make V square subject of the formula. I will have V square equal to N square, H square over 4 pi square. This M square, R square will come down. Now, N square, R square. Take note of this formula. That means I have this square equal to N square, H square over 4 pi square, M square, R square. And recall this one too. I have V square equal to 1/4 pi epsilon naught mass ZE square over R. Don't forget, this square equal to this. This square equal to this. That means I can equate these two. To get radius. I want to get radius of shell of an atom. To get radius of shell of an atom, then equate these two formula. This square equal to this square equal to this. That means anywhere I see this square here, I will change it to this. And we have n square h square over 4 pi square m square r square equal to 1 over 4 pi epsilon naught mass z e square over r. Let us do our mathematics. 1/2 times 1/2. 1n cancel 1n. 1 pi cancel 1 pi. 4 cancel what? 4. What again? What can cancel? What can cancel? So I have n square h square over what will I have left here? Pi n r equal to, in this one 1 times this I have z e square over what do I have left here? I have epsilon naught. I want to make this subject of formula r. I want to get radius. I want to get r. I want to get r. Don't forget. That means what happened? And we have cross multiply. If we cross multiply, and we have n square h square epsilon naught equal to pi m r z e square. Make r the subject of formula. And we have r equal to, all this one we come here, n square h square epsilon naught over pi m z e what square. Collect the constant, those that are constant. H is a Planck constant, is a constant. Epsilon is a constant. Pi is a constant. Mass is a constant. Electron, charge on electron, this E is a constant. Collect those constants. Don't forget, n is not a constant. I told you n varies. When n is 1, that is A shell. When n is 2, that is what L shell. And this Z is what number of what atoms, number of proton is not a constant. That means n and Z are not constant. Collect those constants out, and we have R equal to, this one is a constant, H square. This one is a constant, E naught, epsilon naught, is a constant, pi. Mass of an electron is a constant. Charge is what? Constant. Then into n square over what? Over z. Then from here, if you put all the value of the constant, we have r equal to 0.53 n raised to power 2 over z Armstrong. Take note, this is the formula for calculating radius. Write it down. That is the formula for calculating radius. Radius of a shell. Write it down. You can pause the video and write it down. Pause the video and write it down. Let me quickly give you question. Pause the video and write it down. Take this question. And take note. This formula is applicable to hydrogen atom. Why? Hydrogen atom has what? 1 electron. Bohr atomic model is applicable to what? Atom with what? 1 electron. Or hydrogen-like atom, such as if you have helium ion. Yes, the number of electrons in helium ion is 1. If you have lithium ion, let me say lithium 2+, that is lithium plus, is applicable to this because there's 1 electron here. Bohr is applicable for substance with 1 electron. An atom with 1 electron. Take note of that. Let us do question on this. Let's look at this question. The question says, find the radius of first 3 shells of hydrogen atom. Find the radius of first 3 shells of hydrogen. First 3 shells, that means when n equal to 1, when n equal to 2, when n equal to 3, the first 3 shells. That means when n equal to 1, we find the radius. When n equal to 2, we find the radius. When n equal to 3, we find the radius. And we know that what is the atomic number Z means atomic number of proton. N means for number of shell. First three shell. That means you have to find the first shell, the radius of the second shell, the radius of the third shell. And for hydrogen, Z equal to 1. Atomic number of hydrogen equal to 1. Then applying that formula for Rn1, which is for 0.53 times what? N squared over Z Armstrong. When n equal to 1, we have 0.53 times n for the first shell. For the first shell, let me say first shell. First shell. N is what? 1 square all over atomic number 1 A Armstrong. Therefore, you have 0.53. 1 square is 1 divided by 1. That is A Armstrong. That's first shell of what? Of hydrogen. The number of the radius of the first shell of hydrogen is 0.53 Armstrong. Let's look at the second shell of hydrogen. Second shell, that is when n equal to 2. Second shell, when n equal to 2. The formula Rn2, second shell, 0.53 n squared over Z A Armstrong. When n equal to what? When n equal to 2. Z is still 1 because it's hydrogen atom. We have Rn2, radius of the second shell equal to 0.53 times n is for 2 raised to power 2 over 1. Then A Armstrong. We have 0.53 times what? 4 over 1 A Armstrong. We have 221. We have 2.2 A Armstrong. Take note. We have 2.12 A Armstrong. Then let's look at the what? Third one. The third one, when n equal to 3. When n equal to 3. When n equal to 3. That means when n equal to 3, we have radius. When n equal to 3 for the third shell, 0.53 n squared over Z A Armstrong. We have 0.53 when n equal to 3. That is times 3 raised to power 2 over 1. Z is still 1. We are still talking about the A Armstrong. We have 0.53 times what? 9 A Armstrong. Then punch your calculator, we have that. For radius of third shell, punch your calculator, we have that. Take note of that. Take note of that. If you punch your calculator, 4.77 A Armstrong. Please take note of that. Take note of that. Take note. Let's go to the next one. Take note of that. Next one. The next one is what? Velocity of electron. Velocity of electron revolving round the nucleus. Velocity of electron revolving round the nucleus. To get velocity of electron revolving round the nucleus, I use the formula NVR equal to NH over 2 pi. Take note of that. I need to substitute for this R. And don't forget, recollect, since R equal to N squared H squared epsilon naught over pi n Z E squared. This is for R. Don't forget, when I now put all the constants, I have this. Take note of that. That means substitute for R in this formula. What will I have? I will have NV. What is R? All this. Into N squared H squared epsilon naught over pi n Z E squared equal to NH over 2 pi. From here, what will happen? From here, what will happen? 1n cancel 1n here. This H cancel 1h here. N cancel 1n. Pi cancel what? Pi. What will I have left? I will have V into, I have N, I have H, I have epsilon naught over, I have what? Z E squared. Close the bracket. Then here I have 1 over 2. Don't forget, I want to make V the subject of the formula. I want to make V the subject of the formula. What will I do? I will have V equal to cross multiply. This one come here. I have V equal to what? 1 times this. I have Z E squared over this one. 2n8 epsilon naught. Then V equal to, collect all the constant. Charge is a constant. 2 is a constant. H is a constant. It's a plus constant. Epsilon naught is a constant. Collect all those. This is atomic number. This is the number of shell. They are not constant. They vary. Then from here, collect the constant. We have what? E squared over 2h epsilon naught. Then I will have z over n. Put in the value of all these constants. When you put in the value of all these constants, we have V equal to what? 2.186 times 10 raised to power 6 Zn meter per second. Take note, that is formula for what? Velocity. Let me quickly write it here. V equal to 2.186 times 10 raised to power 6 Z over n meter per second. That's velocity. Take this question. Find the speed of electron in the second shell of helium. The speed of electron in the second shell of helium. Don't forget, helium solution. Helium has atomic number of 2. That means Z for helium is what? 2. And they say second shell. That means N is number of shell. That is 2. Then they say find the velocity, speed, velocity, unknown. Then substitute everything. We have V equal to what? 2.186 times 10 raised to power 6 times Z is what? 2 for helium. Then second shell, 2. What happened? 2 cancel 2. I have V equal to what? 2.186 times 10 raised to power 6 meter per second. That is what? The electron in the second shell of helium. Let's move to the next one to get what? Our kinetic energy. You can pause the video and write all this. Kinetic energy. You can pause the video and write all this. Let us write all this. Okay, let me write this one because I will need this one in calculating the kinetic energy. Let me write it. You can pause the video. Let me write it somewhere here. Let me write it. Please write all this. Let me write it somewhere here. Because I will need it. I have velocity equal to what? Z e squared over 2n8 epsilon naught. I need it. Because I will need this. Take note of that. Let's move. Let's calculate the kinetic energy. Kinetic energy of electron. Let me write it. Kinetic energy of electron. Kinetic energy of electron. Kinetic energy of electron. Don't forget, electron that moves around the nucleus possess a kinetic energy. What is the formula for kinetic energy? We have half mv squared. Half mv squared. That means, what is velocity of what? Electron? That's why I say I need that formula. Velocity of an electron is what? Z e squared over 2n8 epsilon naught. That means, since I have velocity to be this, anywhere I see velocity, I will substitute it to this. That means from here, I will have kinetic energy equal to half m. What is V now? This is V. That means I will have Z e squared over 2n8 epsilon naught. Everything squared. Don't forget, everything squared. Everything squared. Then from here, do the mathematics here. I have kinetic energy equal to half m. This one will give me Z squared e raised to power 4 squared Then this one, 2 raised to power 2 will give you 4. N squared, H squared, epsilon naught was squared. I have this. I have it. Then open the bracket. And we have kinetic energy equal to, this is 1 over multiply. And we have N Z squared e raised to power 4 over 2 times 4 is 8 N squared H squared epsilon naught. Take note of that. Collect the constant. Collect this constant. And we have kinetic energy equal to the constant are mass E. 8 is a constant, Planck constant, epsilon naught. They are constant. I told you Z is atomic number, it varies. M is number of shell, it varies. They are not constant. Collect the constant, and we have ME raised to power 4 over 8H raised to power 2. Then epsilon naught raised to power 2. Take note of that. Then I have Z squared over N squared. Put all this value, those constant, put it, all those value, put it, and we have kinetic energy equal to 13.16 Z square over N square electron volt. Take note. That is formula for kinetic energy. Kinetic energy, let me write it here. Equal to what? 13.16 Z square N square electron volt. Take note of that. Let me quickly do this. Find the kinetic energy of electron in second shell of hydrogen. In second shell of hydrogen. Find the kinetic energy of electron in second shell of hydrogen. Very easy, very easy, very easy. You can pause the video and very easy, very easy. This is the formula. Kinetic energy in second shell of hydrogen. What do we do? We have kinetic energy equal to 13.16 Z square over N square electron volt. Therefore, kinetic energy equal to, they say second shell, that means N equal to 2. Z equal to 1, because atomic number of hydrogen is 1. They say second shell, put everything. I have 13.16 Z, that means 1 raised to power 2 over 2 raised to power 2 electron volt. And we have kinetic energy equal to 13.16 times 1 over 4 electron volt. Then from here, that means we have kinetic energy equal to 13.16. This one will give you times 0.25 electron volt. Then do your multiplication. You have that. Take note of that. Just do your multiplication. You have that. Let us go to one potential energy. You can pause the video and write it out. Potential energy. Potential energy. Potential energy. And don't forget to watch. Punch your subscribe button. Like this video, comment, share with your friend. Jupep student. Don't forget those atomic model of Bohr. Please, they are 5. And that is what we are using to get all these. Take note. Bohr is applicable to what? An atom with what? 1 electron. Take note of that. Let's move further. Let's go to potential energy. Potential energy. Potential energy. Potential energy. PE. Don't forget, the formula is minus Fe times what? Radius. Listen, potential energy of an electron is produced by electrostatic force between the electron and the nucleus. Take note of that. The potential energy of an electron revolving around a nucleus is produced by electrostatic force between electron and nucleus. That is, potential energy of an electron is produced by the electrostatic what? Force between the electron and what? Nucleus. Take note of that. That's why potential energy equal to what? Minus electrostatic force times what? The radius of the shell. Why did I put minus? Because when you have electron falling from infinity towards nucleus, this is nucleus. Electron falling from infinity, this is electron falling from infinity towards what? Nucleus. It decreases in what? In energy. Since it decreases in energy, we put what? Negative sign. Take note, negative sign. Negative sign. Because if it's falling, and as it is falling towards the nucleus, the energy is what? Decreasing. As the energy is decreasing, we put what? Negative sign. That's why we have potential energy equal to what? Minus electrostatic force times what? Radius of what? Of electron. And we have, what is electrostatic force? From Coulomb's law, Coulomb Baba, that say 1 over 4 pi epsilon naught times 1 over r square. Don't forget, I'm sorry, e square over r square, z square. Don't forget, I gave you z e square over r square. I gave you this, z square. If you can remember, that is still there. This one is velocity. I gave you. From here, that we have electrostatic force. Electrostatic is from 1 over 4 pi epsilon naught Q1, Q2 over R square. And I told you Q1, Q2. Q1 is what? The proton charge, which is Ze. Then Q2 is what? Electron charge, which is E. They have the same charge, different word, the same value, but different word, charge. The same value, different word, charge. The same value, different charge. The same magnitude, different charge. Positive, negative. This is number of what? Atom. That's where we got this formula. That means when you change this one, Q1, Ze, Q2, E times E square, Z E square over R square. That's how we got that. Please take note of that. Please. I explained it earlier. Okay, let's move from here. Then times R. Don't forget, times this R. This is electrostatic force. Then, which is times this R. What happened? 1 R cancel what? 1 R. And we have potential energy equal to 1 over 4 epsilon E naught times Z E square over R. You know that I can simply do like this, times 1 over R is the same. You know that. And what is R? Since R, what is R? R. What is R? Since R equal to L square H square epsilon naught over pi NZ E square. I can change this R to this, and we have potential energy equal to, don't forget the negative sign. Please, don't forget the negative sign. This negative sign. Minus 1 over 4 pi epsilon naught times what? Z E square times 1 over N square H square epsilon naught over pi mz E square. Don't forget reciprocal. Reciprocal, this one go up, this one come down. If you did mathematics, if you have 1 over S over 4, it's the same thing as well. If you do the reciprocal, that is 4 over X. Don't forget inverse. That means inverse of this, and we have minus 1 over 4 pi epsilon naught times Z E square. If you do the mathematics, it means times this one go up, this one come down. Pi NZ E square over N square H square epsilon naught. You have that. Then what do we do? What do? Let us do the mathematics. Pi cancel what? Pi. Epsilon cancel what? We have, what do we have? Epsilon cancel what? Epsilon. What do we have again? What do we have again? What do we have again? Which one cancel which one? Do the mathematics. Then let's work from here. Now, let's do the reciprocal. Let me write it here because of clarity. Let me write it here because of clarity. Let me write it here because of clarity. Because of clarity. From here, I have potential energy equal to minus 1 over 4 pi epsilon naught times Z squared times, do the reciprocal of this, I have pi n Z squared over n squared h squared epsilon naught. Then let's do which one that can cancel, which one can cancel. Pi cancel what? Pi. That means I will have potential energy equal to Z squared times Z squared. Will give you what? Z squared. Z times Z squared. E squared times E squared will give you e raised to power 4. Don't forget. Then over, we have 4 n squared h squared epsilon naught times epsilon naught will give you epsilon naught squared. Then collect the word constant. We have potential energy. Don't forget the negative sign. The negative sign. The negative sign. I told you the negative sign, and I gave you the reason for the negative sign. Then from here, we have minus, collect the word constant. E is a constant. E raised to power 4 over 4 is a constant. H is a constant. Epsilon is a what? Constant. You have this. Then Z, atomic number, over number of shell raised to power 2. P E equal to, put in all the constant. Put in all the constant, we have minus 27.2. Then Z square over N square electron volt. Take note of that. Take note of that. Take note of that. That is for the formula for potential energy. The formula for potential energy that is caused by electrostatic force between electron and what? Nucleus in an atom. Take note of that. Take note of this formula for potential energy. You can say find the potential energy of electron in second shell of helium. Very simple. This is the formula. Helium atomic number is 2. Second shell, N is for 2. Put in everything here. You get your answer. Please do that your own. Pause the video. Write the formula for potential energy. Write it down. Then let us go to the last one for today, which is total energy. 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 Total energy is kinetic energy plus potential energy. Take note. Total energy is what? Kinetic energy plus what? Potential energy. Very easy. What is kinetic energy? Change it. Total energy possessed by electron equal to kinetic energy plus potential energy. What is the kinetic energy? 13.16 Z square over N square electron volt plus potential energy is what? 20 minus, don't forget, minus 27.2. Then Z square N square electron volt. Take note of that. Take note of that. From here, we have total energy equal to 13.16 Z square over N square electron volt. This one give you minus 27.2 Z square over N square electron volt. This one are the same. Total energy 13.16 minus what? 27.2 will give you what? Minus 13.16. Don't forget this one are the same. Collect it out. Z x square over what? N square electron volt. That is formula for total energy. Total energy. Total energy. Total energy. Total energy. Take note of that. Total energy. 13.6. Yeah, 13.6. That is formula for total energy. Take note. Total energy. Take note of that. Take note. Those are things you have to know. You have to know total energy, kinetic energy, potential energy, and the atomic model of a Bohr. I told you, atomic model of a Bohr is applicable to what? To atom with only one electron. That means hydrogen-like atom. Hydrogen has only one electron, and hydrogen-like atom like what? Like helium ion, lithium 2 plus, hydrogen-like what? Atom. That means it's applicable to them. Take note of that. And Bohr consider the electron as a moving particle. Take note. Another thing you have to know that, please write it down. Bohr consider electron as a what? Moving particle. And Bohr is one that calculated the position of electron, he calculated the velocity of electron, and he calculated the energy of electron. He calculated the position of electron, the what? The velocity of electron, and what? The energy of electron. He consider electron as a moving particle. Take note of that. In the next video, we shall look at some, and take note, if they ask you, the best atomic model, the best atomic model, that is the next video, is what? Quantum mechanical model by Schrodinger. Quantum mechanical model by what? Schrodinger. Take note, the best atomic model, the best atomic what? Model is quantum mechanical atomic model. Quantum mechanical model by Schrodinger. Take note. Take note. Another thing they can ask you is this. Another name for Ernest Rutherford model. Rutherford model can also be called nuclear model. Nuclear. Take note. Nuclear model. Ernest Rutherford model. Let me quickly, because I saw the question in JAM. Take note of that for JAM students and for JUPEP students. Take note of that. Ernest Rutherford model. Ernest Rutherford model can also be called what? Nuclear model. Take note. But the best atomic model is a quantum mechanical model by Schrodinger. Let us call it a day. I remain myself, Chama.